So in the very beginning of this course, we talked about the SDLC a little bit. In this unit, we're going to expand on the SDLC, which stands for the Software Development Lifecycle. So in the beginning, we showed sort of in Unit 1, we demonstrated a system development project that used an iterative and agile system development lifecycle, which we're going to talk about what those terms really mean in just a minute. But we sort of showed this whole process, how we would do analysis, and then we would do design. There was a little bit of planning in the beginning. There might be some implementation and testing and all that sort of thing. We talked about all these different phases and how that might play out. And if you recall, we did it over a sample project taking 6 days. So we can kind of look at what would happen in each one of those 6 days on one iteration of the project. So in the later chapters, we focused on activities that we did in systems analysis. We just completed talking about system design activities and tasks that we do for system design. And in the next couple of units, we're going to talk about implementation. We're going to talk about database design and things of that nature. But in this unit, we're going to kind of take a step back and look at everything overall, look at the entire process. So now that we've done this systems analysis, now that we've done this system design activities, we're going to see how that fits into the whole model for systems analysis and design. In a traditional course on this subject, we would normally do this chapter first. We would talk about this whole SDLC process, but it's helpful to know what we do in each one of these steps in the process, especially for analysis and design. And then we can really kind of get a sense of how that all fits together in the whole process. So that's kind of why I mixed this up a little bit in this course. So now we'll return to look at the SDLC and related concepts in more detail. So we're going to talk about predictive versus adaptive SDLCs and activities and tasks of system support. And we're going to talk about methodologies and then the models, tools, and techniques that are used within the methodologies. Impacts of traditional versus object-oriented development. And by the way, traditional you can also call structured systems analysis and design. And then what we've discussed in this class is mostly object-oriented systems analysis and design. We'll talk about those two and how they differ. We're going to talk also at the very end, we'll talk a little bit about Agile development, which is really what most people do in modern systems analysis and design. So the system development lifecycle, there are two general approaches to the SDLC. There's the predictive approach, where you might see that as the waterfall model, and we'll talk about why it's called the waterfall model in just a minute. It assumes the project can be planned in advance and that the information system can be developed according to that plan. So usually when we have a predictive approach, we know exactly what the system is required to do, and there's very low technical risk in using that predictive approach. So here's the problem with the predictive approach. Right? This is how you can think of the predictive approach. If you were building a house, or if you were going to design a car, and more so a house, think about this. If you're building a house, you pick a plot of land, you start to do, you might have some architectural drawings and you design the house. You create these blueprints to build the house. And then you start to excavate, you build where you dig the hole where the basement's going to go and you start to put the walls in. And if the owner of the house comes by one day and says, you know what, I changed my mind. I don't really want the house to be in that position. I think it'd be great if we could just move it 10 feet to the left. And if you're the builder and the homeowner comes in and says, yeah, just move the whole thing 10 feet to the left, that's not very easy to do, right? So you can't make those decisions after you've already started building a house. In software development, we do have the ability to make those decisions. We can move the house 10 feet to the left in software development. And in the old days, that was considered something that was, out of the ordinary and something difficult to do in software development. But over time, that thinking has changed a lot, where today, most people accept the fact that once we start developing and building a system, that there are going to be changes. Users are going to discover things that they need to do with the system that they didn't know, or that they don't need to do certain things in a certain way. So that's where we get this adaptive approach to the SDLC. So it's an iterative model. In other words, with the adaptive approach, we don't start with planning and then do all of our analysis and then do all of our design and then implement the system. That would be the predictive approach, where we do all the planning first, just like creating that blueprint. You create the blueprint. Once the blueprints are done and you break ground, you don't go back and change the blueprint, at least not, within reason. You can't, move the building like I said before. But with an adaptive approach, we can do that. So in an adaptive approach, we create the blueprint, we start to do we start building the system, but then we might come back to another iteration and say, we've learned in this first iteration that we do want to move 10 feet to the left, so we can make those changes. It assumes the project must be more flexible and adapt to changing needs as the project progresses, which I discussed. Requirements and needs are uncertain or there's high technical risk. So sometimes, the users don't know exactly what they need in this new system. In your textbook, they give you this nice chart, and they say on the left side, we've got predictive SDLC. On the right side, you've got adaptive. So predictive is where the requirements are well understood and well defined, and there's low technical risk, whereas adaptive, the requirements and needs are uncertain, and there's high technical risk. So again, that's from your textbook, and they show you that sort of transition from one to the other. So you can have, and you don't have to be all predictive or all adaptive. You can have a project that's sort of somewhere in the middle, where you lean towards predictive, but you do have some adaptability in the project. So you can be somewhere in this continuum between requirements are well understood and the requirements are uncertain. You might be pretty certain about the requirements, but there might be some things that you're not 100% on. So you would have a little bit of an iterative approach, but mostly predictive in that case. So a traditional predictive SDLC, or software development lifecycle, this was an earlier approach. It's based on engineering, just like all the other engineering disciplines, where we can't build a house until we have it designed, and so forth and so on. You typically have sequential phases. So the phases are related groups of development activities, such as planning, analysis, design, implementation, and deployment. Each one of those would be its own phase. And in the traditional SDLC, you might use something like the waterfall model, which is where there is no overlap between each of these phases. So you start with planning. When the planning is complete, then you transition to analysis. You do all of your analysis activities, and when the analysis is complete, then you transition to design, and then implementation and deployment. Two things don't happen. Number one, you don't iterate through that process. So you don't get to the design phase and then, we're going to go back and start planning again. That doesn't happen with the predictive SDLC in the waterfall model. And you also can't do two things at once. You can't be doing planning and start your analysis while you're still doing some planning, or be doing your analysis while you're started to do some design work. So in that sense, it's not very flexible. You have to get to that milestone of planning being completed, and then you transition into analysis. So once one phase is completed, you fall over the waterfall to the next phase, and there's no going back. So in our textbook, they have a nice chart or graph or picture of what this looks like. We start with project initiation, and when that's done, the planning specifications are frozen, and we move into planning, and then that's frozen, and we move into analysis. Analysis activities are frozen. We move into design. The design activities are frozen. We go into implementation. The system is built and delivered exactly as specified in the analysis phase, and then finally we do our deployment. So that would be the waterfall model, and there should be no overlap. So sorry with the confusion here in this diagram, but there would be no overlap in these different phases. So a newer overlapping phases are predictive SDLC. So you can do a predictive SDLC, but with overlap, where you initiate the project, you start to do some planning, and then partway through the planning, you start your analysis. While you're doing analysis, you can also do design. And while you're doing design, you might do some implementation, and your deployment could happen, before you finish the implementation, and then on to support. So that would be an overlapping predictive SDLC, which is kind of somewhere in the middle of that continuum that we talked about earlier. So adaptive SDLC, our book says, emerged in response to increasingly complex requirements and uncertain technological environments. Always includes iterations where some of the design and implementation is done from the beginning. This is kind of the model of what it looks like. You got these axes, and we sort of spiral around those axes. So we start, maybe each one of these two axes form 4 quadrants. And one of those quadrants might be planning. The other would be analysis, then building, and then testing. So this would be an example of the adaptive phases of or the phases in adaptive SDLC. So the first phase, we do a little bit of planning, a little analysis, a little building, and a little testing. Or we're laying out the groundwork to do those things. Maybe we're not actually doing any building, but we're kind of laying the groundwork of the foundation to do all that stuff. And then we do a second iteration where we do a little bit more of each of those. So we do more planning, more analysis, more building, more testing, and so forth and so on until we get to the final phase, which is where we're doing the most work, but we're finally producing a workable system in that final phase. So you kind of spiral around, and it's really hard to do spirals in PowerPoint. Otherwise, I would show you a nice spiral on there. But if you can imagine each one of those spiraling, so from 1, we transition into 2, then 3, then 4, and so forth. And in a typical project, you could do 6 to 12 iterations around through this spiraling. In your textbook, this is what they show you. They show you some analysis, some design, some implementation, and circling back to do more analysis, more design, more implementation, and then circling back and doing even more analysis, even more design, and even more implementation. And then we've been going back to this chart over and over again throughout the semester. For each task that I talked about, we talked about which core process this would be. So we talked about these core processes in Unit 1, and each time we talked about something, we referenced where it would fall on these core processes. And I talked about in each iteration how much of it we would be doing. So in that first iteration, or that first spiral around those 4 quadrants, we would do a lot of problem identification and obtaining approval, but we would be doing very little of obtaining approval in, say, in iteration number 4. If we haven't gotten approval by step 4, then we're probably doing something wrong, right? Somebody's going to say, hey, what are you guys doing? Planning would happen mostly in the first iteration, and it drifts off as we go through the project. And then likewise, discovering and understanding the details, we do most of that in the second and third iteration, but that drifts off as we go through the project. Designing happens mostly in the middle iterations, but very little or no design in the beginning or the end. And then building and testing happens more towards the end of the project. And finally, complete system test and deploy is all stuff that starts to happen towards the end. So we don't even start thinking about that until that third iteration. And in the 6th iteration, that's mostly what we're doing. So again, I've come back to this each time throughout the semester to show you in what iteration the emphasis for that core process would fall. So some additional adaptive concepts. Incremental development, an approach that requires that completes portions of the system in increments. So with adaptive, we work incrementally. A system is implemented and partially deployed in steps during the project and gets part of the system into the user's hands sooner. In your book, they also talk about this concept of walking skeleton, which is where it's an approach in which the complete system structure is built early, but with bare bones functionality. So we sort of build that whole substructure of our system. So all the parts are there. They're just not necessarily fully operational. And then we flesh all that out through all these iterations. We're fleshing out all of these, all the different parts of our system in our walking skeleton. So walking skeleton is actually one of the techniques I like to use when I do systems development, because we can sort of structure and frame out the system first, and then we can start bringing in or bringing out each of those different sections can start coming to life. So that's typically how I like to build systems. So in your book, we don't really talk about the support phase too much in this course. We're mostly focused in this course on the analysis and design. And then towards the end of the course, which is the next 2 units, we're going to talk about the implementation phase and database design and things like that. But support is certainly an important part. All information systems need to be supported once they're completed. In the predictive SDLC, support was one of the phases of the project. So usually in the last phase in implementation, they talk about support. But in the adaptive SDLCs, we treat support as a separate project. So we really haven't talked about support much in this course because we're focusing on an adaptive SDLC and with this whole object-oriented systems analysis and design using an Agile approach that our textbook talks about. So support activities are the activities whose objective is to maintain and enhance the system after it is installed and in use. So a little bit more about these support activities. We have maintaining the system is a support activity. So we're fixing any problems and errors, making minor adjustments, updates and changes in operating systems or environments are all being managed during that maintaining the system phase. Enhancing the system. So users might say we have some new functionality that we need from the system to stay competitive or so forth and so on. So that's going to happen. Adding or changing functionality to comply with regulations or legislation. So things that necessarily we couldn't have planned for, but because all of a sudden some change in the regulatory environment requires us to make a change in the software. Supporting the users. So ongoing user training and a help desk to help users when they're having issues. would all be things we have to worry about in the support activities. We're going to talk about 4 things as far as the SDLC. So in our software development lifecycle, we have, in order to complete our software development, most of us use methodologies to do that. Methodologies include models, tools, and techniques. So I'm going to talk about what these are and how they relate to each other. So a methodology is the guidelines for every facet of system development. It's what you do and when you do it, why you do it, and how you do it. So all of that is defined in the methodologies. So it specifies a system development lifecycle with activities and tasks for each phase. So this is where these different phases would be defined and what we do in each one of those phases of the project. It specifies project planning and project management models and reporting. It specifies analysis and design models to create the system, specifies implementation and testing techniques. All this stuff gets defined under methodologies, deployment and support techniques, and so forth. The other term you might hear is system development process. So a methodology, another term for that would be system development process. So models are an abstraction of an important aspect of the real world. A model, by the way, is most of our diagrams would be called a model. It makes it possible to understand the complex concept by focusing only on a relevant part, and each model shows a different aspect of the concept. It's crucial for communicating project information. It's a lot easier to understand models than it is written explanations. So that's why we do modeling. And modeling is not only to help us understand, which we've talked about in the analysis phase, but also to convey our understanding to stakeholders and also convey a design to the actual developers. In information systems, some models are of system components, and other models are used to manage the process. So project planning has its own modeling, which we haven't really talked about in this course. We don't really talk about project management in this course, but your textbook does talk about project management. So you can certainly take a look at that, and there are other courses you could take to talk about project management where you would use project management modeling, things like Gantt charts and so forth. In fact, I think we have a slide here where we talk about those models. So like component models. Component models are what actually describe the system that we are either analyzing or designing, and the models that we talked about are things like flow charts, data flow diagrams, which is a structured technique, entity relationship diagrams, which are from the structured technique, structure charts, use case diagrams, which is from the object-oriented technique, class diagrams, again, that's an object-oriented technique, sequence diagrams, and so forth. The development process models, which are things we would find more in the project management discipline, would be things like Gantt charts, organizational charts, network diagrams, financial analysis like return on investment, net present value, all those types of models are things that we use in the development process models. And again, you would learn more about those in a project management class. So tools are the software applications that assist developers in creating models or other components required for a project. So the tools are the things that we're using while we're doing this analysis and design. So some tools, some examples of tools, project management software, drawing and graphics tools, word processors, visual modeling tools like Visio or Enterprise Architect, integrated development environment or an IDE, things like NetBeans or SQL Management Studio and things like that that can help us design system. Database management tools, reverse engineering tools, which is, you could take reverse engineering tools let you do things like look at a database and develop a database diagram from the database. It'll go in and look at all your tables and all the columns and the foreign keys, and it'll create a whole diagram for you. Code generation. So code generation is tools where you can take your design and it will actually write the code for you. Going back to that database example, some database programs will let you draw tables with columns and create your foreign keys by clicking and dragging between the different tables and columns, and then it'll take that and actually create the code to create the database. It'll actually write the code for you. So you don't have to write a single line of SQL, DML, to when you use a tool like that. Although sometimes it doesn't create the database exactly the way you wanted it, so it's a good idea to have somebody who knows what they're doing write that code if you don't know how to do DML. Or I should say DDL, I apologize. So finally, we have techniques. Techniques are a collection of guidelines that help an analyst complete an activity or task. This course has been mostly about techniques. We're learning techniques for analysis and design in this class, mostly object-oriented techniques. So learning techniques is the key to having expertise in the field as a systems analyst or a designer. So examples are strategic planning, project management, user interviewing, which we talked about, data modeling, which we talked about, database design, which we're going to talk about in the next unit, structured programming, software testing, process modeling, domain modeling. We talked about all that stuff already, and use case modeling, and then object-oriented programming, which we don't talk about in this class, but there are other classes that you will take or have taken to cover object-oriented programming. And then architectural design and user interface design, which we do talk about in this course, and we already talked about both of those. So those are examples of the techniques that we use for systems analysis and design. Methodologies are the process, models are how we describe these components, and then tools are things that we can use to create those, and techniques are what we are learning about in this course. So, and I'm sorry, I should have shown that picture before I said all that, but there's your methodology. You've got techniques, models, and tools, which I talked about. So there are two approaches to analysis and development. There's the structured approach. This was an earlier approach, assumes a system is a collection of processes that interact with data. Structured analysis, structured design, and structured programming, those are all terms that you'll hear with the structured approach. And then you've got object-oriented approach. The object-oriented approach is the more recent approach, assumes a system is a collection of objects that interact and complete tasks. So you've got object-oriented analysis, object-oriented design, object-oriented programming. And again, all those terms you've probably heard before. So again, these are the two major approaches to systems analysis and design, the structured approach and the object-oriented approach. In Unit 1, we mostly talked about the object-oriented approach and what we would be doing throughout the rest of the course. But I also posted under Unit 1 a structured approach, so a video that describes the structured approach to the structured approach to systems analysis and design. So we use slightly different techniques, and I'm going to show you an example of that. So in the structured approach, it's all about sequence, selection, and decision and repetition, i.e. it's procedural. Procedural programming is a lot different than object-oriented programming. We talk about conditional logic and loops, and as an example, if I were describing a system using the structured approach, I'd say that in order, first you would stand up, turn right, walk to the window, look outside, check if it's raining. If it's not raining, put on sunscreen. If it is raining, get your umbrella. Then you're going to walk outside. You're going to keep walking and check to see if you've arrived. If you haven't arrived, you're going to continue walking and check again. And if you have arrived, you're going to stop. So that's how I might describe a system using the structured approach. And, and I'll show you some examples of the structured approach models that we would use. So it's a top-down approach. So it's very procedural. Usually you have a control module, which controls the flow from top to bottom, and the control module could call other modules. So for example, the control module calls module 1, which begins, does something 3 times, and then returns control. Notice the important thing is that only one thing is ever happening at a time when you conceptualize the structured approach. It's a single track. You start here, and there's decision and looping throughout the process, but there's only ever one thing at a time happening. So we don't really have this whole object thing that we've been talking about throughout the whole semester with structured. And in the old days, the only way we could write software was with the structured approach or a procedural approach. We didn't really have objects yet. Here's an example of a data flow diagram, which I did show you in Unit 1. There was another lecture that you could have looked at that showed you the structured approach. I also talked about the entity relationship diagram. I actually showed you this a little bit earlier in the semester. So structured analysis captures events, data flow diagrams, entity relationship diagrams, and that feeds into structured design, which is then used for structured programming. The object-oriented approach is a little bit different. The object-oriented analysis, or OOA, is the process of identifying and defining the use cases and objects or classes in the new system, which is what we talked about in this course, right? The first thing we did is we tried to figure out what are the use cases, who is going to use the system, and how are they going to use the system, and then we use that to try to derive our objects or classes in the new system, which we talked about. Then we used all that stuff from analysis for our design, which is defining all the types of objects necessary to communicate with the people and devices and showing how they interact to complete those tasks. And then that would feed to the programming, object-oriented programming, which is where we would use that design to actually develop or program the system. So writing statements that define the actual classes and what each object of the class does. And again, that's based on the design. Objects collaborate to complete a task. That's an important concept for object-oriented approach. And again, these are the diagrams we've already looked at. This was the design class diagram. This is an example of a sequence diagram. And then we had examples of other types of diagrams, like our communication diagrams and our use case diagrams and so forth and so on, which are our models, as we talked about before, the models or the modeling techniques that we use. So finally in this chapter, we talk about Agile development, which is sort of a buzzword now. You know, you'll hear people say Agile development. What is Agile development? This text emphasizes Agile values as stated by the Manifesto for Agile Development. Value responding to change over following a plan. So in other words, in Agile development, we would rather respond to change than strictly follow the plan. We value individuals and interactions over processes and tools, value working software over comprehensive documentation, and value customer collaboration over contract negotiation. So it's very centric on the process and the software and kind of shedding away the bureaucracy around all that. So, Agile development, a guiding philosophy and set of guidelines for developing information systems in an unknown, rapidly changing environment, which I think is just about everything in IT now is unknown and rapidly changing environments. It complements adaptive SDLCs and methodologies that support it. So if you're doing Agile development, you're using an adaptive SDLC or methodology. It takes adaptive and makes sure developers are fast on their feet to respond to changes. So that's basically what Agile development is. So what we've talked about so far in this class is mostly Agile development. You would take this adaptive approach that we've been talking about throughout the semester, where we do all these iterations, and that would be an adaptive approach or an Agile approach using that adaptive SDLC. So that's basically what they're talking about. So this is the summary of everything that we talked about in this unit. And if you have any questions, please let me know. And thank you for watching.